Hey guys, this is Mr. Schaefer with another quick tutorial here for how to add fractions with unlike denominators. So you can see we have our example problem, 2/5 plus 1/2. And as we've been learning and discussing in class, we cannot add these fractions because the denominators aren't the same. And it's not as easy as just, oh, I can erase the 2 and make it a 5, and then the denominators will be the same. That won't work because if we do that, we're actually changing the value of the original fraction. So our goal is to add these two fractions, but to have a common denominator and also preserve the value of each fraction. So in order to do that, I'm going to rewrite the fractions vertically. So 2/5 and 1/2. And then we're going to make an equivalent fractions table for each of our fractions in our example problem. So I'm going to skip count by the denominators, the 5 and the 2, and I'm trying to find a number that they both will land on. So I'll skip count by 5s. So 5, 10, 15, 20. And then I like to alternate back and forth between both denominators just to see if I can get a common denominator faster. I don't want to keep counting and counting and counting. So I'll skip count by 2, 2, 4, 6, 8, 10. I'm going to stop right here because I remembered in my original 2/5 fraction that I was counting with, I had a 10 in the denominator. Now, in order to find the missing numerators, we need to skip count by the numerators. So I'll skip count by 2. The next number would be 4, 6, 8. I'm going to skip count by the numerator 1, 2, 3, 4, 5. Now, the two fractions that I'm really looking for are the 4/10 and the 5/10 because they have the same denominator. And just so we're clear, when you look at the table, every fraction in this table is equivalent to one another. So 2/5 is the same as 4/10 is equivalent to 6/15 and 8/20. And we could literally skip count to infinity and come up with an infinite amount of equivalent fractions. So back to our original problem, I was trying to add 2/5 to 1/2. We couldn't because the denominators aren't the same. So instead of adding those two fractions, I'm going to add the 4/10 and the 5/10. So I'm going to come up to our original problem. I'm going to rewrite it as, 4/10 plus the 1/2 is now 5/10. And just like we learned in third grade, when we add fractions that have the same denominator, we're going to add the numerators and keep the denominator the same. So our final answer will be 9/10. As always, if you have questions, please don't hesitate to ask. Mr. Schaefer here.